notice that every debate eventually becomes a debate about the definition of words? For example, here's a question. Are wolves endangered? There are like something between 250,000 and 350,000 gray wolves in the wild. And by gray wolves, I mean animals that are named Canis lupus scientifically. And that's a lot of wolves, so definitely not what you would consider endangered, given that something like tigers, there's only like around 4,000 of them left in the wild. And keep in mind that these numbers are estimates, so assuming that they're true, that's where the question applies. But this is somewhat misleading, because if you actually look at a map of how wolves are distributed around the world, you'll notice that they have a very wide territory. And so 200,000 animals spread across this territory isn't that much at all. And there are also these isolated pockets of gray wolf populations all around the world. For example, if you look in North America, outside of Alaska, the range which wolves occupy in the USA is very small. And also notice that there's this little isolated pocket here, and this population is only around 300 gray wolves. And so there are these local kind of areas in which gray wolves are endangered, but kind of globally they're not. And it's a good question, like, should we be focusing on the kind of global picture or kind of on these individual populations? My overall point is that like different pictures emerge when you kind of take into account different levels of context. But there are even more interesting ways to think about this set. Remember the fact that we're defining wolves as animals that are Canis lupus. And I neglected to account for the approximately 900 million members of Canis lupus that live in the world. Because dogs, our domesticated dogs, are a subspecies of Canis lupus. Dogs are wolves. Dogs are a type of wolf. The reason for this is that two different species aren't able to produce viable offspring. So, for example, a donkey and a horse are considered different species because when you crossbreed them, they produce a mule. But the mule itself is unable to produce children. It's infertile, and so that's why we can say that the mule isn't a species. It's a crossbreed between two species, the horse and the donkey. But wolves and dogs don't have this problem. The progeny of wolves and dogs are fertile and are able to produce progeny of their own. And this is why wolves and dogs are considered the same species, meaning that this is a wolf. But funnily enough, not all scientists agree with this classification and don't necessarily consider dogs and wolves to be the same species. And there are also good reasons for this. I mean, think about the fact that dogs are clearly domesticated and wolves are clearly not tame. So there are clearly significant differences, and there might be good reason to talk about these populations differently. Interestingly, while I was looking at this example, I learned that of the 900 million dogs that live on the planet Earth, apparently only 20% are actual like household pets. The rest are stray dogs and like dogs that just were domesticated and I guess live in the wild now. So that's interesting. My point again is that like where we draw the borders of what we're talking about is very significant for the discussion, and the kind of like more we move away from context and avoid context, the more simplistic the picture appears, when really it's actually quite complicated and there's all of these nuances involved. So why did I bring up that whole discussion, given that the title of this video is going to be like the problem with rationality or something like that? That example itself doesn't actually demonstrate the problem with rationality, rather how rationality can be pretty easily misused to create a sense of certainty and kind of independency from context when actually things are rather ambiguous and context sensitive. Rationality is actually a very useful tool if we apply it properly, and don't get too absorbed into rationality itself. The problem with rationality has nothing to do with rationality per se, but rather the fact that we misuse it in a way that degrades its usefulness. So what is rationality? It's probably good to actually define what we're talking about so that we're all on the same page. So rationality is strongly connected with our ability to reason and deduce things using logic. We build arguments using logical statements so that we can come to conclusions which are kind of built upon the premises that we state to be true. Generally, deductive reasoning is associated with rationality rather than inductive reasoning. For example, here's the line of reasoning. All humans are mortal. Nexus void is a human, as far as you can tell. Therefore, nexus void is mortal. There are some interesting properties about rationality because its purpose is to find statements that are definitely true or definitely false given the premises. I'm not saying it always kind of figures things out, but that's its purpose. And again, this largely depends on very precise, clear definitions about what we're talking about. This is why rationality actually makes a lot of sense in a mathematical context. Math is like pure rationality and is in fact probably the best way we use rationality. For example, all triangles have 3 angles. Why is this statement true? It's because we pretty much define triangle in this way, so it must be true. Another fact about rationality is that it's reasoning within an enclosed system. We set up a hypothetical system building these premises, and that's what math kind of is. It's this kind of imaginary world where we assume certain things are true and then kind of figure out what's true given these true statements. The real utility of rationality is in math. Math is like pure rationality in its most basic sense. Math is a kind of invented world where we clearly define things and then follow a line of reasoning which are are kind of implied by the things that we state to be true. For example, if we define a triangle and give it very clear definition, we come to the inevitable truth that this thing, the sum of its angles, must equal 180 degrees. Think about that. We made a hypothetical thing called a triangle and then insisted on it being a certain way and then deduced some truth connected to that idea. And that's why I really mean that math is a virtual world. But it's also extremely cool. I mean, you probably guessed that I'm a huge nerd and that I love math. But like even the idea that 1 + 1 = 2 is a conclusion that you can reach when you define a certain number of things, which is really interesting because I used to think that like addition and adding numbers is just something we assumed and then tried to, find what conclusions follow from that. But it turns out that you can actually state very simple premises, such as like defining what the successor of a number is and defining what 0 is. And then you can eventually reach the inevitable conclusion that 1 + 1 = 2. And I find that really cool. This is actually really fascinating. And we're led to some very strange ideas because of this. For instance, everybody knows what a circle is, but I'll define it as all of the points which are equal distance from some point. So we create this notion of a circle. And by exploring this notion, we discover the idea of pi, which is odd because pi is an irrational number. And this basically means that if you were to write pi out, you would never be able to do it because the decimal keeps going on forever. It starts with 3.14 and then the numbers just continue. There's never a point where it just becomes zeros after that. And think about that. We can actually prove that. We can prove that pi is irrational. And of course, again, this depends on the same thing that we've been talking about. We define what a rational number is. A rational number can be written as a fraction like this. So then we just assume that pi is like that. But then if we assume that, we come to a contradiction, which shows that pi can't be like that, and therefore it must be irrational. This is super cool because we can use logic to prove something which is rather incomprehensible. I mean, that notion itself takes the human mind so far. The idea of a number that never ends, it really opens the mind to the concept of infinity. But if you think about it, there's a question we can ask. Not everybody agrees that math is an invention, but if we did invent something like a circle, like the ideal notion of a hypothetical circle, and then it gives us this thing which is like incomprehensible, the question is pi like just a made up concept? I mean, that's kind of a too philosophical discussion, but I think that the idea of pi corresponds to something even if circles themselves aren't necessarily real objects. There are real objects that can be approximated as circles or spherical. For example, the Earth can be, even though the Earth isn't a perfect circle and there's no such thing as a perfect circle, because, the fact that it can be approximated still makes the notion of pi useful. So it's definitely a useful idea, but we come to this useful idea through kind of a hypothetical idea. But again, that really relates to the fact that we define this very clear thing, we give it very firm boundaries, and then we use logic to deduce what else is true given that. I think this is absurdly fascinating. And it's crazy the number of things we can prove to be true given the kind of basic axioms of math. But there's actually a catch to all of this, and that's the notion that math is actually incomplete. This means that our best systems of math, the most kind of rigid and logical, come with an inherent incompleteness. This means that there are true statements that are true within the system of math, but there's no way to actually construct the axioms and prove that that statement is true. There's a sense in which there are true things beyond our ability to reason and rationally come to them. And furthermore, it's actually difficult to kind of prove the original premises wrong, or prove that they're true. You kind of just have to assume them and then keep going forward. But you can't actually go back and figure out whether the original premises were true, if that makes sense. Like, there's no way to use the system to get back to those premises. The premises kind of are your starting point, and then everything follows from that, but you can't circle your way back. That would produce a logical paradox. Now, that's a big topic in and of itself. I'll put a video in the description which discusses that in a lot of detail. But this basically shows that even though you may think of math as like this very rigid system of truth, it's actually not like that. And you can see what I mean when we apply the idea of rationality to a discipline other than math. Science is many things. I don't want to just give a simplistic definition of what science is, but particularly physics is an attempt to find the rules about reality, the true axioms of reality itself, like i.e., these are the statements that describe our reality, and then we can kind of piece together how the world should behave given those axioms. But of course, the problem with this is that if we set up a bunch of rules and then assume that they're true going forward, we never consider the possibility that the original axioms may be wrong. And in a sense, irrationality, the idea of going beyond those rules, I guess, and asserting new ideas that contradict the original rules, often makes the biggest advances in science. Irrationality advances science in a very profound way. In fact, the biggest leaps in science seem to result from kind of this episode of irrationality. You may think that science is inherently rational, but there's a sense in which that is actually true. But there's also a sense in which irrationality is what produces true knowledge in science. And the example that I always use, and it's a really good example, is Albert Einstein and his theory of general relativity. also special relativity to an extent. Einstein didn't derive that idea by following the logic of what was commonly understood about the nature of reality, particularly how geometry worked. It was just obviously assumed that space is Euclidean. It's a Euclidean plane. That's the most kind of like sensible way to think about reality, and one of the most sensible assumptions about reality. And what does that mean if you're not familiar? It basically means that space just isn't curved, that straight lines go straight and continue in that direction forever, and that parallel lines will never meet. If they just continued forever, if two parallel lines continued forever, they would never meet. Now, it's actually more complicated than that, and maybe I'll put a link in the description that describes Euclidean geometry in more detail, but this again was just a fundamental assumption about the nature of reality. It's pretty like straightforward why that would be the case. Einstein, though, because he's kind of thinking outside of the box rather than constraining himself to this, inbuilt system, is able to deduce that we don't actually live in a Euclidean space because space-time is curved. It is important to know that Einstein was a theoretician, meaning he didn't actually go ahead and prove his idea. He more or less just thought it made sense and then put down the formula. So Einstein wasn't being completely irrational and breaking all of the assumptions about the world, but he did have to break some fundamental ones in order to reach his higher insight. And as a result, he put forth this equation. This kind of is how he describes the universe. This is the equation that describes general relativity, and it's able to explain gravity, something that's actually rather perplexing. And now when Einstein came up with this idea, he was considered genuinely insane by a huge percentage of the scientific community. Because basically what he just said was the equivalent of saying triangles can now have angles more or less than 180 degrees. Because it's actually true in a non-Euclidean geometry. Triangles can have that property. And he was so hated by other scientists that 100 scientists got together and wrote this weird book about him, explaining why he was wrong about special relativity and general relativity. And again, their reasoning is more or less that he's just breaking the fundamental assumptions about nature, therefore that's a contradiction, therefore he's wrong. But here's the interesting thing, because what Einstein did was he was kind of temporarily irrational to reach a higher insight, but then he constrained the picture again by providing his equation. And now you can use his equation to kind of deduce logical truths that must be true given the truth of this equation, if that makes sense. That was a lot of the word truth in there. But essentially, what that means is that if you're a smart mathematician, you can look at this equation and then figure things about the world from this. For example, you can derive this equation, which basically describes black holes. So the object of black holes was kind of assumed by the math of general relativity before the actual objects of black holes were discovered. It was shown that the math could produce objects like this, and that's how we figured out about black holes before we even saw one in space or detected the presence of one. So again, that's actually the usefulness of rationality. Another useful thing about rationality is that if we assume that reality follows basic premises, it makes predictions about reality, and this is what experiments do. Experiments are checking reality to see if our rationality is true. Given that Einstein is right about general relativity and about how space and time work, we should expect during a solar eclipse for the light of the sun to curve around the moon, and that was discovered. So it turns out, in fact, that Einstein's ideas were right. So let's take full stock of what just happened here. By being irrational, by clashing with basic fundamental premises, we are led to a system which allows us to be rational again, and then find interesting conclusions given those premises. So different premises essentially give us different forms of rationality, and that's what different disciplines of math are fundamentally. For example, the idea of topology, I can't give a full description of it, but basically it's assuming that you have shapes that can be transformed in various ways, but then you constrain it and say they can't be transformed this way and they can't be transformed this way. What's true given those fundamental premises? And a lot of interesting ideas are true given those premises. So rationality and irrationality actually kind of operate in these cycles, because higher ideas are found when we kind of break our fundamental assumptions, but then these kind of constrain things when we realize what the actual picture was. One of the problems is that when we form premises and then fail to go back and check if they were consistent and made sense and are reflective of reality. And that's exactly what the scientists who were opposed to Einstein failed to see. They were convinced that by contradicting certain premises, the theory was wrong, but it was actually the premises that were wrong. And of course, in different contexts, different premises are valid. For example, if you're doing physics in a classroom, you don't really need to consider the curvature of space. So you can just act like space is Euclidean and you'll get the right results. So again, different contexts allow for kind of different applications of different premises. Again, the beauty of rationality is very clear in science itself, but the usefulness of rationality, like I said before, begins to break down when we don't really know what we're doing with it, and we're not very rigid about how we define things. So take, for instance, Ben Shapiro being rational about music.
The musical case against rap is that, in my view, and the view of my music theorist father who went to music school, there are three elements to music. There is harmony, there is melody, and there is rhythm. Okay. And rap only fulfills one of these, the rhythm section. That there's not a lot of melody and there's not a lot of harmony. And thus it is basically effectively spoken rhythm. And so it's not actually a form of music.
So this argument is what I would call a misuse of rationality, because he starts by defining music, saying that it must have these things. Then he says rap doesn't have them, therefore rap isn't music. One problem with this is that it creates a kind of self-enclosed system, which is imaginary. It's a fundamentally imaginary world. He's created a set of ideas where music is defined as these things. It has these things. It only has these things. And rap doesn't have these things, therefore it isn't music. But is that actually reflective of the nature of rap and of the nature of music? And again, the whole point of him giving that argument is to produce a sense of certainty, whether rap is music or it isn't music. But it isn't actually as certain as we would like it to be. So we can pretty much define things however we wish so that the claim we are making is true given the premises. But then that doesn't necessarily encourage us to actually check reality to see if, first of all, those premises are valid and if those definitions are sensible. Essentially, the problem is that you can kind of just define things arbitrarily so that whatever statements you make are true. And this misses the fundamental thing, is that we're talking about actual things in the actual world. And this kind of attempt to kind of constrain the picture actually prevents us from seeing what's really there. There's a lot of nuances about rap music that are just lost if you kind of operate in this imaginary world. For example, rap has a lot of similarities with other music, but there are also rap songs that are extremely different from each other. And so no clear way to kind of divide the boundaries. And again, because there's so much variety involved, it's hard to actually give a clear and precise definition of what rap is. But it's also hard to give a clear and precise definition of what music is, because there's lots of different types of music, and they clearly differ from each other in fundamental ways, and it's more or less one of those things you know when you see it. Giving clear, precise definitions to it actually kind of excludes a lot of things which should be considered music. It's not necessarily that our ability to rationalize things is failing to see the true picture. It's the fact that we expect reality to conform to our kind of rational assumptions about it, when in reality is very bizarre. It's not easy to systematize things. It's obviously useful to systematize things, but we should always be aware of the fact that our categories are kind of arbitrary, and where we put the boundary between things is, it's in our heads. But another problem with rationality is that we all have certain assumptions, including me, and we tend to dismiss things really quickly when they seem to contradict our fundamental assumptions, even if we're holding these assumptions relatively unconsciously. That's kind of why if you hear an idea that sounds bizarre, the reason it sounds bizarre, even if you can't consciously think of why it sounds bizarre, is because it probably contradicts something which you know unconsciously to be true, or you assume unconsciously to be true. And furthermore, not all of our premises which we unconsciously have are applicable in every situation. We keep trying to systematize everything and categorize the universe properly, but the actual universe keeps seeming to present us with situations which puzzle and kind of break our definitions. This is exactly why wolves and dogs are sensibly considered the same species by some people, but not by other people. Does this mean we should just give up on our systems and definitions altogether? I actually don't think so. I think that the nature of consciousness depends on producing these kind of internal models, but everything is also context sensitive. So the assumptions that we have in one context may not necessarily make sense in a different context. So we need to be flexible about the models that we use to illuminate the world and constrain the world and kind of, make conclusions about the world. For example, it pays to be willing to consider that whatever assumptions you currently hold don't apply in a new situation, and in fact may be wrong in some situations. That is, in a sense, being irrational. But again, being irrational is often what we need to do to understand the actual complex nature of reality. And again, having too many unconscious assumptions can cause us to dismiss ideas which don't seem to kind of vibe with those assumptions. For example, the assumption of materialism is just that, and a common assumption. And yet many people take it to be very intrinsically bound with science, like an inherent scientific assumption. But in reality, it's just kind of an axiom. You can choose to believe it or not. But if you believe it, you may dismiss ideas which seem to contradict it. And so by having this assumption, you're kind of closing the door on other possibilities prematurely, without being considering opening up the possibility that initial assumption of materialism is wrong. And again, this prevents you from being drawn to some of the more stranger aspects of reality, which would become apparent if you kind of operated under a different paradigm. This is always a problem with rationality itself, because we're always developing a system which reveals something, but that system always tends to conceal something else because it's fundamentally a form of constraint. And again, I would argue that this obsession with constraining things actually makes us less smart because it prevents us from being open-minded, and prevents that open-minded state, which actually produces higher insights and deeper understanding about things. And again, these seem to require us to temporarily abandon our assumptions. Now, this may sound like I'm replacing materialism and putting my own kind of different assumptions and assuming that these are true, and then claiming that my assumptions are right and that materialism is wrong. But that's actually not the case, because I think materialism is a very interesting assumption to have. It is fascinating to adopt a materialist paradigm and kind of see what emerges. And notice that even human behavior seems to be like this dance of particles. And in a sense, that picture does make a lot of sense and is actually quite useful and very kind of engaging to think about. And so sometimes I assume materialism, and sometimes I assume alternatives like dualism, or this other idea that I have right now, which pretty much says that different forms of qualia are fundamentally distinct, distinct from each other. And so it's not like dualism, it's like multi-dualism. But I won't go too much into detail about that right now. But again, through materialism, a very beautiful picture of reality emerges. But through other assumptions, a different picture emerges. And notice that both of them may be valid to a certain extent. Reality isn't like math, where things are definite and certain. It can be described with math, but there's also limitations to describing it with math, particularly related to the fact that math is incomplete. One of my points is that rationality is most useful when we use it to kind of illuminate different aspects of the real world, but it becomes less useful when we remain bound within this system and stuck kind of in the imaginary closed loop. We need to be able to apply kind of different assumptions to a single idea so that different pictures emerge, that we get a kind of more cohesive understanding of a very complex topic. Different kind of assumptions about what we're talking about give us this multifaceted picture. That's why I talked about why are wolves endangered, because if you define things in different ways, you really get a true sense of the complexity of the situation. And very often we fall into the trap of using rationality without checking reality to see if our rationality, gives predictions which predict reality. We're kind of stuck in our imaginary maps rather than looking at the real world and determining how it's construed, which is kind of more related to empiricism, the knowledge from your senses. So again, we don't need to give up on our systems that we develop. We just need to learn how to disentangle the model from the actual things and realize that any model we use to understand the world conceals other ways of seeing the world. For example, this type of model of the atom reveals certain things about it, but this model reveals some other things about it. And it's not necessarily that one model is more accurate than the other, although that could be the case depending on like what you're defining as more accurate. But again, different kind of things, truths about the atom emerge from these different models. We keep wanting precision in a universe that's very often imprecise, and we want certainty in a universe that's actually very ambiguous. So again, where our definitions are and what we kind of constrain needs to be flexible. So how do we kind of fix this problem? Well, I think understanding how rationality functions and its relationship to math and how it's able to be used in math goes a long way for really understanding what rationality is and how to use it properly. For example, do you notice that everybody has different ideas about what constitutes common sense? For example, the statement that memories are encoded in DNA may sound crazy to some people and yet sound perfectly sound to others, because we each operate with different assumptions. It's therefore always important to try to be on the same page whenever we're trying to be rational, and don't assume that your kind of assumptions about the world are the same as everybody else's assumptions. I make that mistake constantly, and I end up looking quite stupid because I just make assumptions that I just assume other people to have, but there's no reason for me to assume that my assumptions are the same as anybody else's. Especially when they're relatively uncommon. So again, clarity is very important, as well as an understanding of the fact that the human mind is obsessed with kind of systematizing and categorizing the world and kind of dividing things from other things and seeing the difference. It's kind of, the left hemisphere very much likes to divide things like that. So that's why we were obsessed with the notion of species. Wolves are one species, coyotes are another. But these distinctions are often arbitrary, and more of a way for us to speak about things than for us to actually understand their true nature. Another thing is that it's probably a good idea to always be open-minded to somebody else's assumptions, provided that they make those assumptions clear. That's why it's really good to kind of make your assumptions clear. This is how we use rationality more effectively. Make the assumptions clear, but then also, if somebody puts forth assumptions which you don't necessarily agree with, try seeing imagine a world where those assumptions were true and seeing what follows. It may actually lead to a very interesting line of reasoning that may make sense, because again, the premises may make sense in that context. There's this beautiful quote from Heretics of Dune, which my girlfriend showed me, which I think is particularly salient to this discussion. By your belief in granular singularities, you deny all movement, evolutionary or de-evolutionary. Belief fixes a granular universe and causes that universe to persist. Nothing can be allowed to change, because that way your non-moving universe vanishes. But it moves of itself when you do not move. It evolves beyond you and is no longer accessible to you. And I think, again, this really speaks to the fact that our systems for understanding reality are just that. They're just systems, but the real universe is, it's much grander than our systems can often accommodate. And this is why it's also really important to be clear about the definitions of words, because what you think words mean may not be the same. What am I trying to say? Basically, I'm trying to say that not everybody has the same definitions of those words that you use. And so whenever there's like any ambiguous language that could be interpreted in other ways, it's important to clarify what that means. And again, people often know exactly what they mean, but they use words that other people interpret differently, and so they're misunderstood. And I guess that's just a problem with language overall, but it does relate to the fact that it's important to be aware of what other people understand and what kind of worldview they're trying to communicate to you. So again, the cycle of rationality and irrationality which takes place shows that rationality shouldn't be abandoned at all, but it's important to know when it's appropriate to be irrational. And this cycle is well demonstrated by 3 Blue 1 Brown, who said in this video, which is about inventing new mathematics.
So, in answer to the age-old question of whether math is invention or discovery, my personal belief is that discovery of non-rigorous truths is what leads us to the construction of rigorous terms that are useful, opening the door for more fuzzy discoveries, continuing the cycle.
And yeah, and that pretty much summarizes this entire video. Anyways, I hope that was fun to watch, entertaining. I hope you learned something. If you want to have discussions with me and others about this sort of thing, it would be really cool if you guys could subscribe to me on Patreon, and that way you get access to our Discord server, and we can have crazy discussions like this all the time. But it would be really cool if you guys were interested in joining our community, and you can do that and have a discussion with me whenever you wanted. But yeah, thanks for watching. Have a great life. Take care. See ya.